Hello, everyone. Welcome to PaaS Application Development. We're excited that you could join us today for Paul Stanton's presentation on simplifying SQL Server DevOps with production databases. This live webinar is delivered by expert speakers from the PaaS community or IT community at large. The webinar will be recorded and a link to the content will be posted on the PaaS Application Development website or PaaS TV after the event. My name is Carnegie Johnson. I'm a co-leader of the PaaS App Dev Virtual Group. I'm always excited to learn from our community experts and to serve our community. I will do my best to facilitate great content and a fun learning environment for us. So before we begin the presentation, I have a few more introductory slides and then I will hand it over to our presenter. Okay, so if you require technical assistance, please type your question into the question pane and someone will assist you. This question pane is also where you may ask questions throughout the presentation. Once we get to the QA portion of the session, I will read your unanswered questions aloud to the presenter, or we may present those questions throughout the presentation. You may be able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that you may receive a short evaluation at the end of the webinar. Your feedback is important to us, so please take a moment to complete the evaluation. All right, call for speakers. So if, oops. Here we go. If you're interested in presenting a PaaS Summit conference session in Houston, Texas, fabulous Houston, Texas, on the dates of November 10th through 13th, this is your chance. So submit your application or your abstract for your speaker session, and the deadline to do so is March 3rd, 2020, and you'll be considered by the selection committee. Also, the PaaS community at large would like your help to direct PaaS and to guide future content. So the PaaS Educational Program Survey is now open. So let us know what content you'd like to see throughout the year and present it at PaaS Summit 2020. Your feedback will help us provide a more innovative, content-driven experience year-round. Now, as a thank you for your participation, you will be automatically entered into a draw for a free registration to PaaS Summit 2020, but you have to submit your survey before March 3rd, 2020. Now, we have many PaaS virtual groups, and the PaaS virtual groups is a global community where data professionals connect, share, and learn. So you have access to hundreds of hours of free online content and recorded live virtual events. So PaaS virtual groups is a great way to connect at your fingertips with like-minded professionals to increase your technical expertise and to grow your career. So you can see application development. We're represented. That's our color scheme, and there are 19 other virtual groups as well with their respective color schemes and names. So the name of the group denotes the primary subject of that particular focus for that virtual group. So today, our presenter for this PaaS App Dev Virtual Group webinar is Paul Stanton. Paul is a proven leader in global cloud product management, business development, and alliances with a passion for results. He is skilled in solution selling and working in cross-functional teams. Paul loves to communicate, to operate with high personal standards, and to develop interpersonal and technical skills. Without further delay, it is my delightful privilege to welcome Paul Stanton presents Simplifying SQL Server DevOps with Production Databases.
Thank you so much, Carnegie. That was a very flattering introduction. I'll try to live up to it. I'm excited to meet with you today, and we're going to talk about new approaches to SQL Server DevOps. We're going to talk primarily about the use of production database clones. This is a new approach to SQL Server development and test support, and we're going to look specifically at how that compares to the use of databases that are built from source, which is a primary method that most organizations use today. Now, a second option that we're going to look at is the use of SQL Server containers compared to instances on a VM. And we're going to combine these things to look at the overall architecture and workflow. And we're going to go through a series of steps in a live demo. And, you know, I think the attendees will find this interesting. Now, I want to encourage people to submit questions as we go. I like to make sure that questions are handled as we go and make this as interactive as possible and of the greatest value to all of you who are attending today. And we'll wrap up with a set of resources that you can use to explore the use of database cloning and SQL Server containers as part of a DevOps process. And I think it's important to begin with a question about, you know, the fundamentals of SQL Server DevOps. And we have to ask ourselves the question, you know, what are the various use cases that we want to address with the DevOps process? Now, almost everyone would agree that development and test is the primary focus of a DevOps process, but I'd also suggest that performance testing, staging, user acceptance testing, and production database debugging as well should be primary goals for any DevOps process. Some would argue that DevOps should address, you know, ETL and data warehousing environment delivery as well, and potentially reporting in BI environments. I tend to think that DevOps should be broadly defined and certainly should address things like production database debugging as a use case. Now, the focus of our session today is going to be on the use of database clones, and I'm going to use SQL Server containers as well. So let's dive into those topics. There are a number of approaches to database cloning available today. Some of you will probably have some prior experience working with database cloning that is supported by storage arrays and storage appliances. All modern storage systems generally support volume-based cloning, and thin volume clones from a storage array will provide a volume with the databases of that environment that can be mounted to SQL Server containers or instances. And this is supported by virtually all modern storage systems. Now, another approach that is probably more widely understood within the SQL Server community is the use of native SQL Server backups to create a Windows virtual hard drive based database clone. My company Windox does this. Redgate offers a SQL clone as a product, and there are also PowerShell scripts available that can take full backups and create a Windows virtual hard drive that contains the databases. A third option is something that we've released this past year is what we call live secondaries, and that's where a database image is updated continually with transaction log backups. Now, the difference between a full backup-based image and a live secondary image is that that full backup image needs to be refreshed periodically and rebuilt using full backups. The live secondary-based images are images that can live on indefinitely, simply being updated with transaction log backups. And then, of course, the clone served off of that image provide more near real-time access to the databases being cloned. The clones that are served from that process are then independent of the continued transaction log updates to that image. Now, all of these environments can deliver multiple databases in a form where the databases are very lightweight. We're looking at a 40 megabyte storage impact. And in all of these cases as well, data masking and other security needs can be applied to these databases at runtime. And so this then provides us a alternative to the traditional process of building dev databases from source control. And let's just take a look now at the main differences between built databases and these database cloned environments. The first point I want to make is that the built database will incorporate the schema and objects of the target database, and static and dynamic test data needs to be created and added to support testing. The curation and development of this stubbed test data takes extra effort and adds a degree of complexity to test development. And that's really the second point, is the tests then need to be developed specifically to go against the stubbed data in step number one. Third point is that databases that are built from source will take a number of minutes per database. With a 4 or 5 database environment, that obviously can add up to be a substantial time. In contrast, database clones are served up in seconds. The test development is simplified because the tests can be written against, essentially the production databases with data masking applied. And then moving to the fourth point, one issue with built databases is that once the testing is completed, as you move to staging and performance testing, obviously the environment needs to be rebuilt. That really works against best practices in DevOps, where a single artifact would support the full CI/CD pipeline. That's simply not possible with built databases. And then finally, it's important to recognize that with built databases, you really cannot effectively address some of the business needs, such as delivering a production database environment for debugging, where again, that's a very good use case for database clones. So this summarizes some of the trade-offs between using a built database versus using cloned database environments. I want to pause here for a minute. Carnegie, do we have any questions? Okay, so moving on. That's a brief contrast of built databases versus database clones.
Excuse me, Paul, can you hear me?
Go ahead, Carnegie.
I'm sorry, I was muted, but we do have a couple of questions regarding audio issues, where some folks are not able to hear, and I am trying to troubleshoot it in the background. But if it continues, we'll just continue on. We'll just post a recording up. But for right now, that's the only issue, the only questions that are coming through, just audio questions.
All right.
Melanie.
Okay, so we have this contrast between database clones and built environments. Another choice that we face with SQL Server DevOps today is the use of SQL Server containers or conventional instances. For those that are unfamiliar with containers, SQL Server containers are equivalent to an instance on a host. The difference is that they come in the form of an immutable image. So SQL Server containers can be created, deleted, and replaced very quickly. They also include the ability to manage a relatively dense packing of containers on a shared host. And this ability to run a number of SQL Server containers on a single VM allows people to achieve a number of benefits. Number one, there can be fewer VMs involved. You can get away from VM sprawl as popular. These things can be delivered very quickly and are immutable so that they provide a more reliable DevOps process support. Maintenance is reduced, and of course, they are, cloud native and Kubernetes ready. So there's a number of benefits to be had with SQL Server containers compared to what are essentially fixed instances. And that will be our focus on the demos and our use cases today. Now, when you put these tools together, you can imagine having a single Windows server shown in the middle, supporting multiple stages of a CI/CD pipeline. You're going to have an image based on a full backup, or as we talked about earlier, it could be an image that's being updated with transaction log backups. You're going to have a workflow that integrates the use of Git or other source control systems. And your environments are going to be served up either from a web UI that developers and testers can use in an ad hoc way, or you can orchestrate the delivery of a multi-stage pipeline using Azure DevOps, Jenkins, and other, CI servers, because the whole thing can be orchestrated with RESTful API calls. Now, one of the steps involved in this process would normally be management of migration scripts. Migration scripts obviously can be ordered via, a naming convention, but I just wanted to share a simple method that some of our clients use, and that's using a PowerShell script with a form of concatenation of scripts. So here we're using get content and set content to create a concatenated script that combines the scripts, involved in your source repo. Now, the process here is if you were to use this process, developers, someone would be updating this script ordering PowerShell script and committing that, updating it and committing that to the source repo. Whenever there's a new migration script being committed, the set order script here would be updated accordingly and also committed. So you end up with a script to order your migration scripts that are included in the repo. And then all of this gets put together in a Docker file where an image is built. Standard Docker command syntax is the Docker build image based on this Docker file and the scripts. And the Docker file here that we're working with is actually included below. In this case, we're working with SQL Server 2017. We're building a full backup-based database clone of the customer's database. The setup cloning full is the command to work with a full backup. And then you can see that we're working with a couple of scripts here. One is a data masking script. Another is that order scripts PowerShell script. And those are being copied into the Docker engine. And then there's an environment variable to use the Docker file to create the container that is designated the things that are going to be run at the container runtime. So you can see we're going to apply the data masking script. We're going to clone our source repo into the container. And then we're also going to run that order scripts PowerShell script. And what we'll end up with then is a SQL Server instance that is also a container with that full database clone of the customer's database. that has been that has data masking applied. And we're also going to have a clone of the migration scripts that are pushed to our source repo. And so let's switch gears here. And Carnegie, can you see my screen? I've just switched over to a VM in the cloud.
Yes, we're able to see your screen.
Okay, very good. So this is, obviously, this is the Windocs approach to SQL Server containers and database cloning. We've got a simple dashboard that shows people the number of containers, also gives us a view of the images and whether they're current with the production database environment. We've got a, I think one of the images here is set up. You can see the new cars clone image is set up to be updated on an hourly basis with the transaction log backups. We have a collection of images here. We're actually going to work with this clone 2 image. And you can see it includes that customer's database that we specified in our Docker file. And the containers on this host are shown here. This is a 2-core, 4-gigabyte server, so you can begin to see that for dev and test purposes, you can do a lot with SQL Server containers on a small VM. And we've got image update monitoring. Again, the clone 2 image is not being updated, but you can see the new car image is being updated periodically with those transaction log backups. And we also have a full audit log of security events that are involved in this system. So you've got, you know, what we have here is an image that will define a SQL Server container. That image is going to be delivered with that customer's database clone. That will be data masked. It will include the clone of the source repo. So we've got access to the migration scripts, the latest migration scripts. If I were a developer coming into the system and Fred had told me that, hey, I've got, you know, I just pushed, you know, a migration script for, you know, a particular feature, all I'd have to do is come in here and I could create a new container knowing that it's going to have all of the latest updates from the repo. So it's a very easy way for developers to collaborate with one another. Another point here is that this is not a shared database environment. This allows the developers to have isolated instances that can be served up quickly and efficiently on this Windows server. So Carnegie, I'm going to pause again and ask for any questions.
No technical questions yet.
Okay. Everyone's being pretty easy on me.
Yeah, I think
we're moving.
Yeah, we've got a lot of issues. We've been dealing with a lot of questions with audio. I think that there has been
That's too bad.
Yeah, a streaming client update, and some of the folks haven't gotten the latest client to get the stream. The sound check works on the desktop client side, but you know the streaming part has to work.
Bummer.
Yeah.
Okay, so I'm going to switch gears again. And what we're going to do is we're going to actually move to let's see here. There we go. So can you see my screen here? Carnegie, we're on Azure DevOps now.
Yes, I see Azure DevOps Demo CI.
Awesome. So we've got our Windows server running SQL Server containers. We've got an image. That image is serving up the database clones. And all of this can be orchestrated with Azure DevOps, but also any other CI server. And so what we have here is a two-stage pipeline. This pipeline is building a testing and staging environments. And there's a YAML file that defines this. And at the conclusion of this session, I've got instructions. You can get this YAML file from us and you can experiment with it. In this case, you can see the YAML files pointing to the server that we were just on. And I've got some user credentials that I'm using to run these tests. The YAML file is aware of the scripts that we're pulling from the source repo. And I'm going to go ahead and kick off a job to build this two-stage pipeline now. And so what's happening is, this is going to initialize and then it's going to make RESTful API calls to that server to serve up a SQL Server container with the that image. So the SQL Server container is going to be served up. It is going to receive some unit tests against that environment. If those pass, then we'll proceed to a second stage of testing in the staging environment. And there we'll be running some more complete set of functional tests. And that is being orchestrated here from, obviously, Azure DevOps. It's actually going against a VM that's running on AWS. So this works well between clouds. It works well going against on-premise servers as well. And the point I want to make here is that this entire process is going to be done, two-stage provisioning and testing environments going to be done in roughly 4 minutes. So in the space of 2 minutes per test, we're going to serve up in a production database environment with a SQL Server container, run the tests, and be complete. And so this really provides a, faster, more efficient approach to SQL Server dev and test. And I believe, based on the feedback from our customers, that this is the new best practice for SQL Server DevOps, is to work with a process that uses containers with secure production database clones. And this will take a few minutes to complete. Where are we at here on this? So you can see we've got the test environment's been built and started. We're running tests on it now. In a few more seconds, we'll proceed to the second part of the testing into the staging environment. And of course, that assumes that the first stage will pass the tests. Any questions come up at this point, Carnegie?
No questions.
Boy, oh boy, I've got an easy audience today.
Yeah, I think a lot of people are probably just troubleshooting, trying to get the audio.
Oh, that's too bad.
Yeah, unfortunately. Yeah.
Well, hopefully the recording will be useful for people.
Yeah, looking at the GoToWebinar audio statistics, it looks great.
Good.
So
you can see now we've gone through the test stage, and we're now building that second stage of the SQL Server CI pipeline. And that'll be complete in a few minutes, or a few seconds rather. And that really provides, the steps and the, demo of this environment. When this is complete, we'll take a look at those containers that have been provisioned from this process. As a matter of fact, let's go ahead and do that right now. Well, actually, we'll let that complete. Oops. As soon as this completes, we're going to go take a look at the environment that was provisioned. Now we've got a typo here. Okay. Yeah, so we've completed the results of the build. You can see we've got 2 environments here at port 10,014, port 10,017. So let's go take a look at that. So I've gone back to the server here. I'm going to pick up my SQL credentials. You'll notice that we support both SQL Auth as well as Windows Auth with Windocs. That's one of the things that you get with Windocs is the SQL Server containers are simply a named instance. I'm going to use the credentials that were used in that CI pipeline though. And you can see we've got the database environment. Here's our customer's database. And so this is a very brief introduction to how database clones can be incorporated into a full CI/CD pipeline. In this case, we're working with SQL Server containers. I think that the combination is fabulous for a modern approach to SQL Server development and test. The same process will support production database debugging and other use cases that arguably should be included in a CI, DevOps process. Now, let's go back to our presentation. In terms of resources to get started, for anyone that's interested, there is a free Windocs Community Edition available at windocs.com. It includes full functioning SQL Server containers, so you can actually implement that same pipeline that we just used here in this session. Contact us at support@windocs.com to get the sample YAML file. That YAML file can simply be uploaded to the source repo of Azure DevOps account, and you can configure that IP address and set up your SQL logins, and away you can go. So it's a very simple way to get started with Azure DevOps using database clones. I also want to mention that Redgate is a popular solution for SQL cloning. So visit redgate.com. And of course, Microsoft has SQL Server containers available. Now, Microsoft's SQL Server containers really focus heavily on Linux, but there are also some images available for the more recent Windows SQL Server containers as well. That really concludes my session, Carnegie. And we're way ahead of schedule. Normally have more interaction during these sessions, but obviously that's not the case today.
Yes.
Carnegie, do you have any questions or anything that you think we should cover to make this session worthwhile?
No, I don't have any questions for you directly, Paul. And I'm looking here in the question pool. We don't have any questions related to non-audio questions related. I am going to send out a chat to everyone to perhaps ask those of you that can hear us, if you would give us some feedback regarding your GoToWebinar audio statistics and your GoToWebinar client version, just so to help us kind of troubleshoot this for the future, because it looks like half of people could hear it, half people couldn't hear it. So maybe there's some other issue that's going on there. I appreciate that. but we can go to our Q&A slide. Okay, there we go. All right, so we'll go ahead and wrap up our live session for this presentation. And a big thank you to our presenter, Paul, and for his patience, and also putting it out there for questions. But we also want to allow those of you to ask questions. If you're going to view this recording and you were not able to do it during the live presentation, please visit our LinkedIn group and post your questions up there. Follow us on Twitter as well at PassAppDev, and include the SQL Pass hashtag. And remember, we've got upcoming webinar this week, Become a T-SQL Pivoting Ninja in 60 minutes or less. If you haven't registered for that, you can go to appdev.pass.org and register for that. And with that, I'll turn it back over to Paul before we close out.
Well, once again, Carnegie, just thanks for the opportunity to present. I hope people will avail themselves to the recording and the LinkedIn group for any questions. I also can be reached at pauls@windocs.com. And thank you so much. It was nice to meet you, Carnegie.
A pleasure. Okay, everyone, take care. Have a great day.